You've just finished your exam. You hand in that paper, walk out of the hall, and then that huge question hits you. What happens now? It really feels like your answers just vanish into a black box, right? Well, today, we're going to pry that box right open and see exactly how the whole system works. It's not just a teacher kind of glancing over it and picking a grade. Nope. There is a super structured, rule-based system that every single examiner has to follow, to the letter. And honestly, understanding that system is the real key to understanding your results. And to show you exactly how it all works, we've gotten our hands on the official documents, a real AQA GCSE Chemistry paper. And this is the important part, its mark scheme. This thing isn't just a list of answers. Think of it as the secret rulebook for the people who are marking your paper. Okay, so to understand the rules, we first have to learn the language. Examiners use a pretty specific vocabulary, so let's just quickly break down a few of the most important terms. First up, allow. This is a fantastic word to see on a mark scheme. It basically means there's a list of different but equally correct answers. So if your wording is a little different from the textbook, but it's still scientifically correct, this rule means you can still get that mark. Phew! Next, we've got ignore. This is for when you've written something that isn't exactly wrong, but it's not really what the question was asking for either. It's neutral. The examiner is literally instructed to just skip over it and look for the parts that can get you points. It doesn't help you, but crucially, it doesn't hurt you either. And then there's ECF, which stands for error carried forward. And let me tell you, this one is a potential grade saver. It means if you make a mistake in a calculation early on, but you use that wrong number correctly in all the next steps, you can still get all the later marks. See, they're testing your method, not just whether you can hit the right buttons on a calculator. But while some rules are there to help you out, others can be incredibly strict. Let's look at one of the most common traps students fall into, where adding just one extra incorrect piece of information can completely wipe out an otherwise perfect answer. So here's a pretty standard 2-mark question from the paper. It seems simple, right? What's the test for hydrogen, and what happens? Most students know this one off by heart, but it turns out how you write it down is absolutely everything. Let's compare 2 different answers. Student A gives a perfect, to-the-point answer. That's 2 marks, easy. Now, student B gives the same correct answer, but they also add and a glowing splint. Well, a glowing splint is the test for oxygen, not hydrogen. So how many marks do you think student B gets? 1, maybe still 2. The answer might actually surprise you. So what did student B get? 0. Yep, a big fat 0. And it seems harsh, but this shows a really critical rule. The mark scheme is crystal clear. Right plus wrong equals wrong. The second you introduce a contradiction, like mentioning the oxygen test, it cancels out the correct part. The examiner has absolutely no choice. The takeaway here is huge. Be accurate, and don't try to hedge your bets. Okay, so that last rule was pretty brutal, but the system also has rules designed to help you, especially when it comes to those long calculation questions. This is where showing your work isn't just good advice, it is your safety net. Take this question, for example. It's a 5-mark calculation based on some experimental data. Now, you might think it's all about getting that one final number right at the end, but in reality, that final number might only be worth 1 of those 5 marks. Just look at how the marks are actually given out. You get a mark just for picking the right data to even start with. You get another for calculating the mean correctly, a third for putting the numbers into the equation, a fourth for rearranging it, and only then a 5th and final mark for the correct answer. You could get 4 out of 5 marks without ever getting the final answer right. And remember that error carried forward rule we talked about? Let's say you messed up step 2. You calculated the mean wrong. If you then used your wrong number correctly in steps 3 and 4, you would still get those marks. Examiners are trained to reward your scientific thinking, even if your arithmetic has a little slip-up. Okay, finally, let's tackle the big ones, those dreaded 6-mark extended response questions. These are the ones where a lot of students think the trick is just to cram in as many keywords as they can remember. But the mark scheme, well, it tells a very different story. Take a question like this one, which asks students to plan a whole method to test for 2 different ions. Just listing flame test or silver nitrate is not going to cut it. The examiner isn't just ticking off a keyword checklist. They are assessing the quality and the logic of your entire plan. So how are these big questions marked? It's not about counting points. It's marked by level. A level 1 answer just kind of identifies a few relevant things. A level 2 answer has most of the right steps, but they're not really in a logical order. But to get to level 3, the top marks, your method has to be logically sequenced and it has to actually work. It's about thinking like a scientist, not just spitting out facts. So, after peeking inside the examiner's secret rulebook, what have we actually learned? It's not about finding some sneaky loophole. It's about understanding what's really being tested so you can show what you know way more effectively. Here are the 3 most important things to take away. First, be precise. Don't add extra fluff that might contradict your right answer, because remember, right plus wrong equals wrong. Second, for calculations, your method is everything. Show every single step to scoop up method marks and get help from error carried forward. And third, for those big 6 markers, think structure and logic. A clear, workable plan will always beat a random list of keywords. It kind of leaves us with the final thought, doesn't it? We think of exams as just a test of our science knowledge. But after seeing all these hidden rules, it makes you wonder, are they also testing how well you understand the game you're playing? Something to chew on.